Hi everyone.
Morning.
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 Thank you for coming to our talk today. My name is Jonathan. I'll be the MC for Group 7. We are thrilled to have you here and hope you find this session insightful. It's my pleasure to introduce our speaker, Yong Chi Heng, who has been with Rocket Factory Augsburg for 3 years as a flight computer / power and loop engineer. Yong Chi Heng is an embedded programmer who specializes in low-level embedded programming. Thanks to his background in computer engineering, he is also comfortable with electronics hardware and FPGA design, in addition to his software programming expertise. Yong's job scope at Rocket Factory Augsburg ranges from programming microcontrollers / MCUs to developing and implementing new functionalities / features for the flight computer. He also engages in data analysis utilizing Python modules like Plotly, Matplotlib, and more. Today, Yong will share insights into the skills RFA looks for in candidates, current hiring criteria and processes, what RFA expects from students and potential employees, and also how to prepare for interviews and job listings at RFA. Please join me in welcoming Yong Chi Heng to the spotlight.
Hello, everyone. This is my. Can you guys hear me clearly?
Yes.
If I
No
can, then
problem.
I'll just bypass the mic since this thing is annoying to carry around.
Right.
And yeah, before I start the presentation, I would just give you a few words first. First of all, I'm really grateful for this opportunity to be able to share my experience with my fellow university students. In case you guys don't know, I'm not a full-time employee. I'm also a university student, like you guys. I hope that you guys we can all learn something from each other from the presentation today. And also I'm severely jet lagged, so apologies in advance if my speech is a bit incoherent, but I'll try my best. Right? Without further ado, let's get started. Right. So, in case you guys missed it, my name is Chi Heng Yong. Although most of my friends and colleagues prefers to call me Chai. I am a student, computer engineering student, or as in German they call it Technische Informatik, in the University of Applied Science Augsburg in Germany. And I started working in RFA as a working student in the flight computer department since 2021. Although recently I also started writing my final year project, as you guys call it, or my bachelor's thesis with them. So that also makes me into a thesis student, I suppose. I joined RFA back then in 2021, as I say, during my first semester break in Germany, where I was trying to find something to do. 3.5 months of not doing anything, that's pretty boring. I can't really come out because tickets are really expensive. So a housemate of mine that was working as an intern in RFA introduced me to this job. They needed an embedded programmer, so I got it. Did 3 months of my internship there, and they were happy with me. So they asked if I wanted, if I could stay and work for them as a permanent working student. And since then, I've been working for them. It's been almost 3 years now. Let's say 2.5 years. Yeah. So next, I'll introduce a little bit about RFA, or Rocket Factory Augsburg, in case you don't know what it stands for. RFA is a rocket company, as you can tell by the name. It was established in 2018 as a subsidiary of OHB SE, which is another satellite company in Europe. And our mission is basically to mass produce rocket. So how do we make rocket production a lot cheaper so that in return, how do we make space flight or space travel in general cheaper, right? So when you think about rocket companies, you can think about companies like maybe SpaceX, or even Blue Origins and stuff like that. And companies like this typically make money from delivering satellites nowadays, and those SpaceX companies that are more capable like that also do what do you call that, like deliver astronauts to the space station and whatnot. RFA hopefully eventually will do something similar, but for now our goal is to make rockets that deliver satellites and stuff as shown over there. So the rocket that we are making is called RFA-1, and there's a small size launch vehicle, you could say. And as previously mentioned, it's used mainly for delivering satellites and stuff. The rocket itself has 3 different stages. Stage 1, which is like the top, stage 2, the middle one, and stage 3, the longest one, as you can see over there. And we make our own engine, which is not very common for rocket companies. A lot of startup rocket companies usually opt for buying engines from other companies because engine development is very, very complicated. But in order to keep the cost down, we decided that having our own engine and also having an engine that we built from the scratch is better for us as a company, since if we understand the engine from the inside out, we know how to optimize it and maybe potentially lower the cost even more. And also it's like kind of like a huge flat, so we like to do that. And the engine that we make is called the Helix engine. We use it on the first 9. We use 9 of them on the first stage, and 1 of them on the second stage and the third stage. The engine is what they call a staged combustion engine, which is how do I put it? It's a kind of liquid propellant rocket. Liquid propellant engine that uses 2 kinds of rocket propellant. RP1, which stands for, it's basically a kind of kerosene that they use in aircraft and stuff. And LOX, which is the short form for liquid oxygen. And when RFA was established back in, my bad. When RFA was established back in 2018, we only had about 15 to 20 employees, so not a lot of people. And today, RFA has grown into a company with more than 370 employees, with people from over 40 different nationalities and stuff. And yeah, it's a really, really, really diverse and interesting working place, I would say. And here are some pictures that of us taking some group pictures of us that we took with the rocket before we send it to the spaceport in Shetland, which I'll talk about a little bit later. Maybe you can see me there with the little white t-shirt that I'm wearing. Right picture. So RFA is in Augsburg, Germany, at least the HQ, but we do have offices and we do our operations in many other European countries too. For example, we have one, the third stage is being developed in Portugal, and we do most of our engine tests in Kiruna, Sweden, basically a mining town. And finally, we do our launch, where the place that we launch our rocket is in this place called the Shetland Islands. Maybe some of you guys will know it. So the Shetland Island is basically located on the northmost part of the UK. And recently, somehow, the UK government had decided that they wanted a spaceport there. So they started building one. It's rural enough, there's barely anyone there, there's mostly sheep and birds. So they just decided to make the spaceport for rocket companies like us that we ran the sport there and then launch our rocket. It's apparently the first licensed vertical launch spaceport in the UK for polar sun synchronous orbit, yada yada yada. All you need to know is that it's a place that we can legally send something up to space. And so why is that so important? Essentially, it's boils down to 3 basic reasons. So it's really, really close to Germany. So logistically, it's very cheap and it's just easier for us to deliver things around. And we get a lot of money from the UK government, so there's an incentive there. And finally, and probably the most significant one, is that there are just not many options in Europe for us to launch rocket. Europe is very, very highly populated, unlike America, where pretty much launch anywhere you want in Nevada or somewhere like that. But Elon Musk mainly prefers to launch his rocket in Texas for this reason. It's next to the ocean and stuff like that. So, before we continue, this is like a video of RFA, but this is what we call a static hot fire test, where we clamp down the rocket and we just fire up the engine and see how it performs before we get everything ready for the first one. Enjoy. During that time, it was pretty emotional for me as well, watching this live actually over there. I was fortunate enough that they sent me up there for like 1 week to basically, I was there dealing with some stuff and also working on some of the IT and cabling stuff over there. So I was fortunate enough to witness this in real life. That is what happened. So, yeah. But moving on. Now let's talk a little bit about the department that I work for. Not everyone in the rocket company works on the engine, although that's like arguably the coolest part of the rocket and the most important part of the rocket. I work on the flight computer, which is here. I'm getting into it now. So the flight computer team is part of the GNC department, or GNC basically stands for Guidance, Navigation and Control. The department is basically responsible for literally how the rocket moves as it enters the orbit and all that stuff, right? So when does the stage 1 detaches from the main body, and when does the stage 2, blah, 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 blah. You get the point. And so the flight computer team, as I mentioned, is part of this department. And our main responsibility is to develop software for the flight computer. So we just program the flight computer, you want to put it simply. And we do this we do this by basically, like for example, coming up with a standardized communication protocol for the entire rocket. Since every component on the rocket, every sensor and stuff needs to at some point talk to the flight computer itself. So it makes sense that we have a common language between each of the devices on the rocket. And implementing such communication protocol is one of the main responsibility of the flight computer team. I'm pretty sure anyone here that are software engineers are familiar with TCP and stuff, right? They're essentially the same thing. It's very similar. We'll get into that here. And another thing would be integrations, MATLAB, Simulink, blah, 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 blah. Basically, Simulink and MATLAB would be you guys heard of it, right? Probably. Yeah. So those are basically the two main software or programming languages, if you could call Simulink a programming language. We use them to develop most of the flight software, since it's a lot easier to do that. They cost more, but oh well. And the flight computer itself, as I say, maybe I said this now, it's basically the brain of the rocket. And it controls whatever the rocket does. So all control algorithms and stuff like that, none of this would have happened if there is not a main brain or a main computer telling the rocket where you're at where and what you should do next and stuff like that. So it's not anything too special. It sounds a bit intimidating maybe, but it basically is just a normal computer in a really fancy black box. An airplane, a Boeing, or something would have used the same thing. Runs an i7 4-core and with 8 gigabytes of RAM, that's it. And remember I mentioned about the communication protocol thing? This is the communication protocol that we use. We call it the Space Packet Protocol. It's not unique to RFA. It's in fact an industry standard that most aerospace companies use. Like any other protocols, it basically just encapsulates data in a very specific structured format before you send it out to the entire network of the rocket. So yeah. Here you can see like the in-depth, the details of how, what do you call it, like the big structure, if you will, of the entire protocol. The main thing that you have to look for is over here in the primary header, where you can see packet type, which is about 1 bit long, and application process ID or API for short. So this two essentially determines if this packet is a command. For example, like it determines if this thing is a telemetry packet or a command type packet from the flight computer to some device asking you to shut down or something. A telemetry packet would be something like, let's say you're a sensor and you're trying to give your whatever data you're collecting to the flight computer so it can do its stuff. Right. And also the flight computers, one of the other things they do is that it communicates with the ground station so we understand what's going on. Moving on. The MATLAB and Simulink thing that I mentioned about here. So this is a bit difficult to explain, but I'll try my best to do it. But essentially, MATLAB and Simulink are two different languages, right? Kind of. And our flight computer only runs C++. It only understands C++ and Python. It's a very basic. It's relatively basic. We made our own operating system for it. It's Linux-based, in case you're wondering. But it can't execute MATLAB and Simulink directly. So what we have to do first, usually, is that we have to first we have all the flight algorithm written down already in both of these languages, and we convert or translate them into C++. And through this thing called the RFA library, which is also another thing that the flight computer team develops, you can think of it as an API, which basically it's a collection of tools and stuff that we created to ensure that all of this algorithm and stuff that we made that is automatically converted into C++ gets nicely fitted into the rest of the flight computer. Otherwise, you just have a bunch of algorithms without like anything to like map it to the flight computer. Anyone that has worked with microcontrollers and stuff, then probably know mapping GPIOs. Well, up to the next part. Here are some cool stuff that I did at work. Specifically during my internship, I thought they were pretty cool, so I might share it. This is a ground station GUI that I made using YAML and this stupid thing called Jython. It's basically a system health monitor for the flight computer. And yeah, as I mentioned, it's created by this software called YAML GUI tool. It stands for yet another mission control language or system or something like that. And it's Eclipse based, so it's anyone here has used Eclipse before. Your professors are nice. Eclipse is, anyone that has used Eclipse would know that it's not exactly the most enjoyable IDE to use. It's really ancient, a bit outdated, but it's free. So a lot of companies like to use this as like what do you call it, like a backbone for making their free IDE and stuff. If you work with STM32 microcontrollers and stuff, STM32 chip and all this stuff, they use Eclipse as the backbone for the entire IDE, and then they sell you for like I don't know 500 euros a month. And then each of the widgets here you see they can be controlled using, you can write script to them to control the behavior, and like remember the space packet stuff that carries all the data and stuff. You can basically pipe those data to each of these widgets so that it displays them accordingly. Right. And the script is written in Jython, which is basically shitty Python. Like can't really think of any better way to say that. And Yeah, then this is a dissector that I made for making Wireshark. So, anyone here familiar with Wireshark? Anyone with studies cybersecurity or networking and stuff like that? So Wireshark is basically a monitoring tool for network monitoring. A lot of hackers like to use this because this basically displays what are the current network traffic on your whatever network your device is connected to. And it's good for debugging. Let's say you're making a website and stuff like that, and you're wondering if why a specific callback is not working and stuff like that. Why is a website not refreshing appropriately? Wireshark sometimes can be helpful to see if your whatever callback function that you're using is actually sending the HTTP request, and you get the point. And Space Packet Protocol, which is the thing that we use in the company, is not a conventional protocol. It's built on top of UDP and TCP, so it's actually a higher level protocol, right? And so in order to effectively debug Space Packet Protocol, we need to first tell Wireshark, hey, this protocol that we're using here we use it on this IP address, and it has the structure of this. And it's the entire dissector thing, we call it. It's written in Lua. If you play Roblox, you probably know what Lua is. And yeah, if everything is done correctly, you should be able to see, like, for example, there, for that specific IP, you can get space packets, which is the thing that we're trying to look for. And when you click on it, all the information about the headers and all the information about like what data is contained within this header and stuff is all shown there. Right. And this one is a CLI tool for logging space packet. So same, more or less serves as the same purpose as the previous tool. It's for debugging space packet protocols that are running around the rocket. Except this one is just for saving everything from Wireshark into a pickup file, which is a file format that Wireshark automatically outputs as you're trying to save something. It's nothing too special. I made this using Python, and I mainly want to show it because I put a Google face on the camera. Right. And finally, we can get into probably the most important part in the presentation, which is who do we look for in the company. So unfortunately, I'm not a HR personnel and stuff, so I can't really give you guys too much of good advice when it comes to what's the most effective and surefire way of getting hired and stuff. But what I can tell you is what my department at least look for when we are conducting like an interview and stuff. What do we look for in our new applicants? So in general, these are all cliche stuff. We want engineers who are passionate in space stuff. Obviously, we are making rockets. And bachelor's and master's students are welcome. If you're a PhD researcher, it's even better. But essentially, a startup company like RFA relies a lot on working students and interns to save books. We don't have a lot of money, and we are trying to build a rocket. Shit gets expensive. So interns and working students are always nice. And finally, independent, motivated individuals, take nature development program. So yeah, very ChatGPT generated stuff. Yes, but it is true in a startup company, things are not as well structured and established. So we do tend to look for interns that shows a bit of promise that they know what they're doing for the most part, and they are more, you can say, smarter and take initial moves. If you exhibit this kind of like traits and stuff, then yeah, good. And we know that you don't have to be babysitted 24/7, and we can rely on you. And general interview tips, I guess. What do we ask in interviews and stuff? At least in my department, we will always start with background questions, like where are you from, what's your nationality. Sounds a bit discriminatory, but sadly in the aerospace industry, there are certain nationalities that people that we cannot really hire. For example, people that are from foreign countries that are actively engaged in war, and we can't also hire. I believe we can't hire Russians and people from Iraq and stuff like that. Unfortunately, due to the situation. But other than that, should be fine. And obviously, your relevant experience. What have you worked on before, right? And Then some technical questions about some projects that you mentioned in your CV. So, which brings me to another point. Please don't lie. I've seen way too many people do this. Some of my friends did this. It did not end up well for them. If you're not good in C++ or if you're not good in Python, please, for the love of God, don't put 4 stars or 5 stars on the CV. You're not lying. You're not fooling anyone. Especially in a company where if you're applying as an engineer, in an engineering firm, your interviewers are engineers. If they see you have 5 stars in C++, they're gonna ask you questions related to C++ or anything that you put in there. And when you couldn't answer it properly, it's gonna look bad on you. They're gonna think you're lying. So the general rule of thumb is that I would say be honest. If you don't know, don't put it in there. And what's that? Put it in there. And yeah. And if they ask you something that you're not really sure about, let's say some data structures, questions and stuff. You've seen those like YouTube videos of how people interview software guys. If you don't know, just tell them you don't know. Be honest, and we appreciate honesty. And we don't expect our applicants to know everything anyways, so no worries. And I guess with that, that's it. Yeah, that concludes my presentation. I hope
Thank you, Mr. Yong, for the splendid presentation. I would like to extend our. Now will be our Q&A session, and I will be passing my microphone to my roommate, Chika.
Yeah, hi sir. So basically we collected some questions from the audience here and from our own group also. So since this is an employment trend module, the first question I'm going to ask is about work culture. So what do you find is the most special / you find interesting, or something you want us to know about the work culture at your company or at Germany?
I would say for me, the most special one is 100% how diverse the entire company is. As I say, we have more than 40 plus employees from different nationalities. Unfortunately, there are only 2 Malaysians there, me included, so it would be nice if we had more Malaysians, but whatever. It's really nice. Working with people from different backgrounds and stuff, you can really, I know science doesn't really change. You're not a better engineer because you studied in America or you're from America or you're from Europe and stuff. No, you study the same thing all around the world. But it's very interesting to see the way people work and the way people think first and how they approach problems. And also really funny when the Italians do this. And we have a lot of Italians in the company.
Okay, cool. Since it's like at Germany,
Yep.
and like personal question for me actually. So like, did you learn the language before you studied there, or?
Yes.
Oh, you did.
Yes.
Was it hard to get used to
New language.
the new language?
I don't want to encourage. I don't want to discourage anyone, but to me, it's probably one of the hardest things I've done in my life. It's probably harder than the actual degree itself, in my opinion. Yeah, like especially when you have to do your entire degree course in that language, and a language you're not super familiar with, can be challenging sometimes. But you know, Indian YouTubers are always.
Yes.
Okay, understood.
Yeah, they do the same thing in Germany nowadays.
Okay. Since the company was established in 2018, right?
Yeah.
I assume when you joined, it's still considered a startup.
Even now, we are still a startup.
Still a startup, right? So, like for us going into internship, right? What do you think of, like, because we get to choose, I mean, we don't really get to choose, but okay. Would you recommend like us landing our internship / first job in a startup more, or like to a big company if we can, of course?
Very, very good question. I'm extremely biased towards startups because I myself am benefited heavily by one, as my company is considered a startup. But my friends did their internship in BMW and Audi would probably disagree with me. But I would just list out the main differences. Would be in startup, like I mentioned in the presentation, things are extremely unorganized and unstructured. Can be very unstructured at times. And you kind of need to be self-organized, and you won't be babysitted 24/7. And also the tasks that you're given are, in my opinion, much harder than the tasks that you're given in a fully developed, well-established company like BMW. Most of my friends that did their internship with Audi and BMW, I don't want to talk trash, but man, they literally did the bare minimum, and they get paid 2,000-3,000 euros for the internship. It's actually crazy. And meanwhile, in startups, you don't get paid much, and you don't get paid much. Like in IFA, for example, we pay about 800 for interns, which in some cities is barely enough to cover the living expenses, sadly. But if you can handle all of this, I would say you learn a lot from startup company, mainly because of the culture. You get to do a lot of things from the ground up. When everything is already well established, you are just joining a system that is it's already functioning. It's, at least for me as an engineer, it's more fun when you get to work on stuff yourself, right? The R&D and stuff like that is what engineers strive for and what engineers loves. But yeah, that's just my opinion.
Okay, thanks. So it's basically one you get more experience, but harder one you get.
More money.
Yeah, you get your point.
Yeah. Okay, cool. So some other questions. What advice would you give to students that is interested in pursuing the career in your field? Or you can understand this question as what advice would you give to your younger self?
What advice would I give to my younger self?
Yeah.
Stop making shit. I'm not even kidding. You're an engineer. You don't really, especially most of us here are from what I heard from Shenkan, a lot of you guys here are software guys.
Yes.
Yeah.
The nice thing about software engineers is like, I'm a computer engineer, right? So I'm half software too. So it's nice because for us to start projects is very easy, since we don't have to spend a few thousand on like a 3D printer and stuff like that. Although having one is very nice too. But let's say making a website, whether or not it's making a game or making a website or making a little Minecraft server and stuff like that, you can start projects like this very easily without any cost, as long as you have a working computer and an internet. So my advice for electrical engineers, I would say microcontrollers are nowadays getting more affordable. Work around with Raspberry Pis, work around with IoT stuff. Anything, it doesn't, let's say you're interested in rocket or like cars and stuff like that, right? You don't have to exactly build a rocket in order to join the company itself, right? As long as you work on something. IoT stuff is extremely useful even doesn't matter if it's in rocket industry or or a car industry or whatever. Since every modern device nowadays requires electronics and requires software at some point. So anything that you know, anything that you learn from the most basic stuff, even for building website, will be beneficial, will benefit you greatly when you join companies like this. So yeah, start making stuff.
Understood. I agree on that.
Yeah.
Also, speaking of this topic, actually, like, is there any concepts or topics that you wish you listened to the lecture during the university?
I wish I liked electronics a little bit more back then. When I first joined the course, I'm just getting a bit personal. When I first applied for my university, my first choice was actually computer science, and computer engineering was my second choice. Because after my A-levels, I realized that I was really good at math, but I wasn't super good at physics. So having to study electrical engineering scared me a little bit. And so when I joined, I was more, I always told myself I'm more of a software guy. I wanted to work more on programming and stuff. But as I progressed more and more in my career and stuff, especially for me, computer engineer, we work a lot with microcontrollers. At some point, you need to mess with circuit boards and stuff. So if you're not good with electrical engineering, you're missing out on a lot. Like you have to ask your electronics colleague about like why you designed it this way, why do you have two stupid resistors over there, why are they like this? And they kind of dictate the entire design of the electronics and the microcontroller is there for you to program, yes, but the rest of the circuit is done by them, and you get no say in this because you're not really good at it. So I would say if I could go back, I would pay a lot of attention in the fundamentals.
Yeah, it's always about the fundamentals.
Yes, sir. Yes, sir.
Yeah, yeah, okay, understood. So I'm just going to ask last like 2 questions, and since like the previous answer was more towards electrical engineering, right? So
Yeah.
I'm just going to ask from software point of view, like is data structure and algorithm like we have been learning, is it like actually being applied? Is it actually useful? Is it?
Yes.
Yes.
Definitely, but it also depends on what field you work in, I guess. Like for embedded programming, since your microcontroller is so weak, right? So you don't really work with a lot of since there's no classes in C, for example, you don't really work with object-oriented designs and stuff like that, right? Most you can do is like linked list or whatever, but in real life, linked list is very inefficient, and let's just say we don't try your best to not overcomplicate things. Like a lot of the stuff that we learn in university are amazing, but a lot of them are also very situational. Most of the time you can get by using very simple stuff, because remember, even if you're a genius and you can implement something that is super complicated and maybe increases the efficiency by 10%, you guys could reduce the complexity by this much. But if there's no, it's not good if the other guy that comes over and helps you with it doesn't understand what the hell you're writing, right? So always be considerate, always try to simplify things, I would say. Yeah. Did I answer your question?
Yeah, and I assume optimization is important too, like in terms of writing the code.
Premature optimization is the root of all evil. Don't try to optimize stuff when it's not properly built yet. Always try to aim for a minimum viable product, so it's something that is working already, then try to optimize it. If you try to optimize it before it's even working, most of the time it leads to a bunch of bugs and you're gonna cry debugging it, so don't do it.
Okay.
That's just my opinion.
Yeah, okay, understood. So my last question here is, what technology or innovation are you most excited about in the aerospace sector?
Most excited about. I am actually very interested in rovers and stuff. So Martian rovers and things like that. We have a few companies in Germany that does that too. It's called the Exploration Company. At some point in the future, I might join them. Yeah. Other than rocketry, I think anything space related is usually more interesting and fun to me, since it's such a new field, right? And when can you tell? Where do you see like people usually talk about like space stuff? And that's it.
Yeah, okay. Thank you for the insights. That's all for our questions. Actually, I pass it back to our MC.
Thank you, Gina, for the Q&A session. I would also like to thank everyone for joining us today. I would like to also extend my gratitude to our guest speaker, Yong Chi Heng, for the insightful talk. We have also prepared a token of appreciation for the speaker, so I would like to call up our group leader, Samson, to present the tokens.
You want to take a picture together?
Interesting. Landscape.
We take 2 pictures.
It hasn't even.
Group picture.
Make it balanced. It's a very to side.
You guys want to come here?
Is it going here? So face cannot see.
You want to stand here?
Your face cannot see. One, two, three. One more. One, two, three.
Thank you.
I'm only back for like, and then I'm going back to finish up everything, maybe do my business. Well, at least another few years. Learn as much as possible. Yeah. Thank you. Sorry, I'm presentation.
Here you go. That's for you.
Brother. Brother. Only have a question.